Me, I would say Eric and then Oliver and then that guy and then
Because I suspect I know what Oliver's going to ask, so I'll ask something different. Maybe I'm wrong.
Yeah,
Okay.
disturbing the conditions of
What I'm about to say might not be in tension or conflict, what you said, but it's not clear to me, so I need to ask. So on your reading of Newton's understanding of inertia, this follows from his conception of the relativistic character of his theory. But I always thought that he had this picture of inertia because, in fact, of what you referred to, and also what George was talking about, that for him, real forces are forces of interaction. So any force, including the inertiae, simply can only be instantiated by interaction. So if a body is just there on its own, nothing else impinging on it, there can be no force. There can be no activity or of any kind because there's no interaction happening. So is that just wildly wrong? Do you think? Is that right? Or is that
right?
what
I just
you're
think it's
saying?
something that he struggled to arrive at.
But I don't see the connection with that with the relativity part.
Well, because early on he's thinking of inertia non-relativistically as a kind of power to maintain your velocity. That's what had to change before he starts to think, well, inertia is a force of a sort that actually it only works in interaction. It's not actually working to maintain a body in its state. That's the part we were all confused about when we separated impetus and inertia, right? Impulse and resistance. That's the sort of pre-relativistic distinction we had to overcome in order to see it this way.
Look, if you put up the quote that you had about how it's exerted this way and that way, and that's exactly the answer to it.
I mean, there's
Okay.
yeah, I mean, it's not just that Leibniz went on for a long time. Many other people went on for a long time thinking of a kind of passive power of resisting as being different from the active power of maintaining your motion. And Newton himself was under that confusion for a while until he started gradually thinking more relativistically, first with the relativity principle, then with reconceptualizing inertia. This is what is essential to my claim that he wasn't just somebody who got the principle of relativity. The theory of relativity idea is that he realized these things had to be understood differently, that everything, in a sense, had to be understood differently.
Well, so my question was actually going to be on exactly this. So, but it's slightly different. So I was not seeing in this quote quite the evidence for relativity or embracing a theory of relativity. So as I understood your claim, you were suggesting that the difference was meant to be a kind of frame relativity that he was accepting.
Yeah.
But it seems that you've got this relativity between whether you've got this inertia of a body, and you can either understand it in terms of that body's resistance to having its state changed, or in the interaction, that body's power to change the state of another body. And that's the relativity. That's the relativity of resistance versus inertia. And what he's pointing out is that whether the body's truly at rest or truly moving, you can think of it as in either way. Although, as you know, although resistance is commonly attributed to truly resting bodies, well, resting bodies, people don't really understand what truly resting is, so the relativity he seems to be pointing out here between resistance versus impetus seems to be orthogonal to embracing a relativity of a frame relativity.
No, but that's it seems to me that's exactly what he's saying. The distinction between impetus and resistance is just a relative distinction, right? Did I mispunctuate something?
No.
The motion and rest in the popular sense of the term.
Right, he's
are
saying the
distinguished from each
reason
other only
why,
by point of view.
the reason why this distinction between impetus and resistance persists in people's minds is because they think there's a real distinction between motion and rest, but that's not something we know physically. What we know physically is what a body's inertial mass is, and that's what we measure. We can measure it taking the body to be at rest, we can measure it taking the body to be in motion, but it will measure the same thing in the same way. And that's what he wasn't getting until now, because he kept thinking, like everyone else, that impetus was one thing and resistance was another. So from this relativistic point of view, that they're the same. Now, which influenced which isn't really clear to me. It may be that he saw Huygens' application of the relativity principle and embraced it and realized, well, eventually, not immediately, but eventually, that this distinction has to go too, and that inertial mass is one thing that looks different in different frames of reference.
And by the way, if that popular is vulgus, that's what he calls in the scholium the relative quantities. The popular sense, if that's vulgus, that's what he calls the relative quantities in the scholium on space-time, right? The properly speaking and the vulgarly speaking.
I think he does say vulgar.
Yeah, so that aligns. I'm supporting you.
Oh, good.
Yeah.
So,
Okay. So I was wondering sort of how far the relativity goes, I guess. So you've made the case that he's got this principle of frame relativity, which would seem to, frame relativity of motion. But at some point he says, well, before that part, but clearly I would say that forces, in that they're sort of real interactions between bodies, are not frame relative. They are invariant.
Right.
But at some point he says, and you had this in a quote that you, on a slide that you skipped, so I don't remember where it is. He says that the true motions are something that we can only determine through looking at the forces. The forces are sort of the causes of the true motions. And presumably that's what he eventually means when he says, well, the best way to look at the solar system is that the sun's in the center, because those are where the motions accord with the forces. But that seems totally commensurate with this frame relativity you're postulating, but it does also seem like he's saying there is a privileged set of reference frames, and that these are in some sense importantly different from the others.
Oh, that's absolutely right. One could argue that corollary 6 sort of extends the relativity principle, except I think that's not quite right. I mean, I think it gives you a kind of, I said it's a quasi-relativity principle, just because in Newton's conception, which isn't, after all, it isn't Einstein's view, right? Newton's view is there could be, and in fact in the world we live in there are, forces that are so peculiar that they act proportionally to mass. They have the same effect empirically on all bodies in roughly the same range, and therefore you can actually treat the system of Jupiter as if it's at rest, even though it's orbiting the sun. But that doesn't mean it really is equivalent to being at rest, because after all, it's involved in this interaction with the sun.
Okay,
And
good.
this is
Yeah.
part of, the third law is part of Newton's conception that would prevent him from thinking that corollary 6 is an extended relativity principle, because after all, there aren't forces accelerating a system from without, unless there's something out there doing it that's in interaction with the local system.
So in other words, I take you to be saying that when he says here, bodies commonly regarded as being at rest are not always truly at rest, what he's saying from our contemporary anachronistic viewpoint is that sort of kinematical, motion-based idea of rest is the wrong one, and we've got to shift to a dynamical view of rest.
Yeah, I mean, I think this remark was related to this whole distinction between impetus and resistance, right?
Right.
So he's thinking of familiar cases like, if there's a billiard ball on a table, and you hit it with the cue ball, well, then the cue ball is overcoming its resistance because it's at rest, right? But of course, that's the wrong way to think of it. That's the vulgar common way of thinking about it, where, yeah, the 8 ball is just sitting there, waiting for something to try to disturb it. Whereas in fact, it's moving through space, it's, it's rotating with the Earth, right? So what you're doing is it's two bodies in relative motion, each of which has a definite mass, and there's going to be an interaction between them. And there's no, in principle, physical reason to think one of them is at rest. It's just because it's in my basement on my pool table, then I think it's at rest.
Yeah, so, you brought out nicely how you had the principle of inertia, what I was called the Galilean relativity principle. That the physical laws should be invariant over the whole class of inertial frames. So he has the notion of an inertial frame, very much as it appears later in Einstein's 1905 paper. But he doesn't. So what do you say though about his treatment of absolute motion as absolute acceleration, the absolute status of, or frame invariant status of rotation? So in a bucket of experiments. He takes that as, I thought, he took that as an argument that you still need absolute space to make sense of that. Whereas from a modern point of view, you have the apparatus of inertial frames, and so you can relativize to any inertial frame. They're all equivalent, but take any one of them, or take them in toto as an ensemble, and it's relative to those frames that you have absolute, you can make sense of absolute acceleration.
Well, I think he partially understood that point. Limited by the fact that he really didn't see a way of characterizing these relative spaces that are all equivalent, except by thinking of them as moving about ultimately in absolute space. Right? So, for example, he believed that you could tell the rotational rate of the Earth from various centrifugal phenomena.
Sure.
And he believed that that was independent of the fact that the frame of reference in which the Earth's center of mass is at rest is moving around the sun. Right? So he understood clearly that there are rotating bodies whose rate of rotation is physically measurable, and these are moving they're at rest in some frame of reference, but if so, that frame of reference is still in motion. And after all, the whole system of the planets is revolving around the center of mass of the solar system, but we don't know if the whole solar system is moving uniformly or at rest.
So I would say that's a problem of application of the theory, and it does put us in a bind because you may have the conception of an inertial frame, but we can't find it. We can't find any inertial frames.
Well,
Naturally.
that's true, but for Newton, it was enough to be able to find a nearly inertial frame.
So one can approximate,
Right.
which is something we learn to live with in physics as well as philosophy.
But that was the point of his remark about the whole solar system possibly being urged by parallel accelerative forces in some other direction.
So, but anyway, I think one message of your talk is that he was much closer to a relativistic view of space and time than we normally think.
I think he was as close as you could be without actually developing the conception of inertial frames. No one got any closer until the late 19th century, I think.
You credited Huygens with as being a possible source for Newton on this matter. What about Galileo himself?
Well, Galileo is very unclear, right? We don't know how carefully Galileo distinguished the tendency to persist in uniform motion from the tendency to persist in uniform circular motion. I mean, it's certainly right to give Galileo the credit for the relativity principle. I mean,
Right.
Some people call it the Galileo-Huygensian principle because it was Huygens who really first articulated it clearly and who spelled out that it's just a uniformly moving system in which impacts will happen as if they were at rest.
We're pretty much out of time, but if you can make it a quick question,
Okay, I'll try to give you the short version. You said that the Newton's theory of absolute space is an instrument, but you're not calling him an instrumentalist. And
I think he fits the pattern that Howard Stein mentioned. People who use instruments even though they have a basically realist view of things.
right. Okay. So in some of your other work, I have read you as saying something like that the theory of space and time given in the scholium is to be read as sort of a stipulative definition of a conceptual tool that sort of enables Newton to do what he did, or am I reading that totally wrong? And I guess what I really wanted to ask you is, have you sort of shifted in how you read the scholium?
Well, I never said it was a stipulative definition.
Okay.
I said that it's a definition because this is something that I'm even more convinced of now that I see, since I wrote that book, that all this history has become clear to me. He defined absolute space and time and motion because he didn't want them to be understood in any other sense than what he says there. It doesn't mean that, I wasn't suggesting that this was in any way arbitrary or disconnected from what he really thought the world was like. But he actually wanted to say, I mean this by space and nothing else. And now I would say even more, well, he has a special reason for introducing absolute space because he wants to make a distinction between absolute space and relative spaces. And he wants to be able to say we have a robust solution to the solar system problem, which doesn't depend on our knowing motion in absolute space. And that's, in a sense, the whole reason he introduces it, right? If you could reach that Cartesian ideal of having an unambiguous description of motion for every body, that the contiguous bodies criterion was supposed to supply. The only one that would make sense would be to know how something is truly moving in space. But we can't know that, and moreover in physics we never need to know that. And I'm still going to solve the problem of planetary motion for you, if you just keep reading.
David, can I just have a postscript, not a question? Rob and I did not, for contingencies beyond our control, we did not coordinate these two talks. And I, in particular, suppressed the space-time part of Howard's claim about the metaphysics that you brought out perfectly. I simply wanted to acknowledge they are complementary, but we didn't actually.
Because you went first.
I'm sorry, David.
time for maybe a 5-minute break.